Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking this up from the topic of integration, where we are finding the areas of the region using integration. And if I talk about the question which is given to us here with respect to this topic, the question tells us that the area which is bounded by the two curves, first curve is given to us as y equal to mod of x minus 1 plus mod of x minus 2, and the other equation given to us is y equal to 3. So we need to find the area which is bounded by these regions, y equals to mod of x minus 1 plus mod of x minus 2 is, and y equal to 3 is equal to what? And we have been given four options that say 5, 4, 6 and 3. So we need to find out which one of the following is the correct region or the correct area of the region between these two curves. So first of all, let's understand the two curves. So to understand the two curves, first if I talk about the concept which we are going to use here is the same which we have already discussed previously in absolute values as well. So if x is positive, we use the idea that mod of x is equal to x. So whatever is present inside the mod, you write it as it is. But if x is negative, I will write that mod of x which is present inside the mod which is negative, I'll multiply that with minus 1. So that makes it minus x. So if you see x being positive, the answer for the mod is positive. Here x which is present, it's negative. We are multiplying that by minus 1. So minus of minus, that also turns this entire thing as positive. So we are keeping our concept clear with this, that mod of anything always turns out a positive value, whether it is negative or positive inside the mod, right? Now let's talk about the question. So it is given to me that the curve is y is equal to mod of x minus 1 plus mod of x minus 2. So if I use the idea of critical key points, the first step, if I equate whatever is in the mod with 0, what I get is x minus 1 equal to 0 gives me x equal to 1. If I put the other value, x minus 2 is equal to 0, it gives me x equal to 2. Once I get two values of x, if I plot them on the number line, one is x equal to 1, the other is x equal to 2. So basically that divides your entire region or number line into three regions, where one region is x less than 1, the other is x from 1 to 2, and the other third region is x greater than 2. So let's analyze our entire curve in these three regions. So if I talk about x less than 1, I had y as mod of x minus 1 plus mod of x minus 2. Now if I put any value of x less than 1, let's say 0. So 0 minus 1, this is negative. So whenever a negative expression is present inside the mod, you multiply that with minus 1 plus, if I put 0 here as well, 0 minus 2, that's also negative. So you multiply that also with minus 1. So you get this expression y is equal to minus x plus 1 minus x plus 2. So y becomes minus 2x plus 3. That's an equation of line that we have for x less than 1. Let's see the other idea. For x from 1 to x to 2, if I talk about this expression, again if I write that same idea, now when x is between 1 and 2 or from 1 and 2, if I put any value, let's say 1.5, 1.5 minus 1, this is 0.5. So this is positive. I'll write it as it is. Here if I put 1.5, that turns out negative. So when a negative expression is present inside mod, you multiply that with minus 1. So plus minus 1 into x minus 2. So that gives you x minus 1 minus x plus 2. So basically this gets cancelled and you get y as 2 minus 1, which is 1. So you get y equal to 1 for x from 1 to 2. And if I have the third x greater than 2, so y, if I am again keeping mod of x minus 1 plus mod of x minus 2. For x greater than 2, let's say if I put 3, 3 minus 1 is 2. So expression inside the mod is positive. You write it as it is. Here also if I put x as 3, expression inside the mod again positive. You write it as it is. So you get y as 2x minus 3. Now let's try to plot this entire curve of y equal to mod of x minus 1 plus mod of x minus 2. So if I try to plot this curve, I have been given y-axis and let's say this is your x-axis. Your y-axis and the x-axis. Now we have 2 points of differentiation here. One is x equal to 1, other is x equal to 2. So at x equal to 1 to 2, we know that y is equal to 1. So if I plot that as well, let's see. So y equal to 1, so I get one point as this, the other point as this. So from x equal to 1 to 2, we know y is equal to 1. So if I plot that line, I get this. Now we know x less than 1 gives you y equal to minus 2x plus 3. If I compare it with y equal to mx plus c, I get y-intercept is 3 and the slope is negative. When the slope is negative, we get a descending line. So I will have a descending line with y-intercept equal to 3. So 0, comma 3. This is your y-intercept. If I draw a line which is passing from this point, passing through that, let's see. So if I have that line, your curve will look something like this. And the other curve, if I see, that is y equal to 2x minus 3. If I try to solve that as well with comparing y equal to mx plus c, slope is 2, y-intercept is minus 3. So if I see that line, I have minus 1, minus 2, minus 3. So here somewhere it is intersecting and it is an ascending line. So your line passes through like this. So if I see that line as well, I get an understanding here that this is your curve present. So if I erase this, I don't need this entire line. I only need the part after 2 because it is falling after 2. So if I just draw that line, after 2, your line would be something like this. Now I get the understanding since it's a positive slope, you have a ascending line. This is y equal to 2x minus 3 and this is y equal to minus 2x plus 3. So this is your entire curve that you have for the first part. Y equal to mod of x minus 1 plus mod of x minus. So this is your entire curve for all the values of x. Now let's see the other curve which we have been given is y equal to 3. So if I draw that region, y equal to 3 will be a straight line which will pass like this. So if I see the area bounded between the two curves which is given, that's nothing but a trapezium. Because this is y equal to 1, this is y equal to 3. Since both of the lines are parallel to x-axis, the two lines would also be parallel to each other. Because of that, the area for which the figure which we have to find out, that becomes a trapezium. And if I have been asked to find the area of trapezium, I will be using the idea half into sum of parallel sides into height. So let's find the coordinates to find the sum of parallel sides. So I know this coordinate is 1, 1 and this coordinate is 2, 1. This we know y is equal to 3. So if I put y equal to 3 and if I solve this equation of line, putting y equal to 3 here, you get 3 plus 3, 6 is equal to 2x, x is equal to 3. So you get y and x both are 3. So from here, if you see the length of this parallel side comes out 2 minus 1, which is 1 unit. And the length of this parallel side comes out 3 minus 0, which is 3 units. So area of trapezium becomes half into sum of parallel sides, which is 1 plus 3. And if I see the height, height is nothing but the perpendicular distance between the two parallel sides. And the perpendicular distance is y coordinate here is 3 and here it is 1. So 3 minus 1, that is 2. So height becomes 2. This gets cancelled. You get 1 plus 3, which is 4 square units. So you get area of the region bounded between the two curves as 4 square units. And if you see the option that matches here with the question, it is option B. So B is the correct answer for the question given to us. That is asking us to find the area between the two regions. One was y equal to mod of x minus 1 plus mod of x minus 2 and y equal to 3. So you have to use this idea entirely in the question of absolute values. If something is positive inside the mod, you keep it as positive. If something is negative inside the mod, multiply it with minus 1. That gave you three regions and we analyzed all those three regions. We got three lines. We plotted those three lines for the values of x. We got this curve for this entire expression and y equal to 3. When I plotted, I got this region between the curves, which was a trapezium. So I just needed to then find the area of trapezium. That gave me the answer as 4 and that matches with option B. So B is the correct answer for the question given to us. I hope you have understood how to solve this type of question which deals with finding the area between the curves and the curves are given to us in absolute value form. I'll see you again tomorrow with some other question from some other topic. And we are going to continue our series of questions on JEE Mains. So stay tuned for more videos to roll out. Also, do like, share and subscribe to my channel. Do share these videos with your friends who are involved in this preparation of questions on JEE Mains. Thank you.